Hi, good day everyone. Uh, it's now July, right? So fast. Probably in the next few weeks, okay, you will have your tests, okay? So today we will go into the, I would say second last, okay? I will try to finish it by the next lecture, right? So that you can prepare for the upcoming test. Okay, I know you will have a lot of tests. Okay, I'm not sure whether you have any final exam uh, in August, right? So let me know in the comment box, right? But then we will try and plan it, right? So this is just a sharing now to discuss about the tests, right? So for this course, you will have another 2 tests to replace your final exam, and the test itself, each of these are 1.5 hours. So when you total up these 2 tests together, it is become 3 hours. So it will be something similar to your normal final exam, right? So to run this test, we will run it similar to your first test, right? But the only difference is that you have to get ready with your own paper, write down your matrix number, and then by that time when everyone ready, I will let you turn on the paper, right? I mean download the paper, and when everyone done, then you can start to answer, right? So the time would be 1.5 hours. Then after finish, you just have to scan your paper using your mobile phone. All right, so you just take picture, good picture, right? Okay, so make sure you write using pen, okay, clearly shown, right, with your matrix number for every single paper, and then you submit it, right? So that would be on the test, right? So now back to before I forgot, uh, just to remind you, you have your assignment, right? So make sure you are working on it, right, and submit on time, right? So now we will go into our sessions now. Okay, so on the belt and chain drive, right? So uh, we have briefly discussed about this, okay, where it is used, right? So you have seen this slide before, okay, where the belt and pulleys, okay, and the chain and sprocket, okay, so their idea is to have 2 rotating part, okay, connected by a belt or a chain, right? So the functions, again, it could be used to change speed, right, or to change directions, or to amplify the power, okay? So this belt and chain, we would call that, also combine them together and call them as a flexible drive, okay, because it is flexible, okay, you can adjust, okay, the locations, okay, this is flexible, right? So we call that as combine them together, we call that as a flexible drive, okay? So these are the rotations things, right, how it would see, and then you can again calculate the theoretical speed and torque accordingly when you know one of these, okay? And we also go through this, right? So now as we have discussed previously also, when we try to design for any system, okay, that's involve movement, right? So in here you may have a motor, okay, to drive maybe a machine, okay? So this is a driving machine, okay, through various combinations of drive, okay? So in these systems you can see that there is a belt, there is a gear, okay, and there is a chain, right? So this could be the combination. So it's up to your desire requirement, right? And then from here, this is your driven machine. So this driven machine can be anything from maybe centrifugal pump, okay, to pump fluids, oil, or whatever it is, right? So now we will talk about belt drive, okay? So again, we will just quickly go through the ideas behind it, okay, or the constructions of the belt itself, right? So it typically used to reduce speed, okay? Main usage is to reduce speed, okay, because generally the motor will move at a very high speed, okay, and we intend to reduce it to a usable or acceptable speed, okay, for our machines, okay, because also the machines could not move at that fast, okay, whenever we want to maybe pumping certain things, okay, so that would not be drive is to reduce the speed from very high to a very low. At the same time, it increase the torque, okay, or the force that it can push, okay. So generally it consists of two shafts, okay. So this shaft is this one, right, or we can say a pulley, right? It's the same name, right? Pulley or shaft, okay, with a belt installed around them, okay. So this installation, you would see that there is a dotted here, okay. Internally inside the belt, actually there is a support, okay. It can be a wire mesh, okay. It's a metal, okay, that bring the solid part, okay, to the belt itself. So now again, we can say that the belt drive, there are several, okay. They can have a flat belt type, okay, the common one, flat, okay. Synchronous belt type, okay. In your car, we may call it as again another name as timing belt, right, with like a gear type, okay, but it is a belt, right. The cork belt is something similar to the timing belt, right, something similar, right. And the most widely used is the V belt, okay, the V belt, right. Instead of a flat one, this is a V belt, okay. The idea of this V belt is that we need to increase the contact surface, okay, because this contact surface is the one that move or to transmit power from one end to the other, okay, through these frictions, alright. So if there is a slippage with this surface, then the power is not properly transmit to the belt, okay. So therefore this contact area is important, right. So these are the examples of the belt constructions, okay. You can have the simplest one, okay, to multiple band, okay. So you can have a 3 shaft, right, 3 strain, and so on, right. Again, we can have the belt being installed in different way, right. So when we drive it in these directions, therefore it will throw the belt over here, and it cause this become a slack side, right. Whereas because this is the driver side, the driving side, so it will keep pulling, so this side will be a tight side, right. But if you want to have a tight side on the top, then you have to pull on the reverse side, okay. The belt is a flexible drive, okay, where you can also change the way you want to install it, right. This shown the cross or twist belt drive, alright, and this one is the quarter turn, okay. This is the rotational and it turns 90 degree, right. We call it quarter turn belt drive. Okay, so this one is short, okay, so we don't really need the guide pulley, okay, whereas this one is maybe long, okay, so you need additional guide pulley in between them to guide it. They also some cases, okay, you may need a idler pulley. Okay, idler pulley means a pulley that doesn't being drive or not being driven, right? So it's just idle there, okay, but then it will also rotate. Sometimes the slippage on this idle pulley is okay, right? You don't care about that. The idea of this idle pulley is to tighten the belt, okay, when it's under the operation. So this would be useful, okay, when because when we install the belt, right, we have to insert into the groove of the pulley or the shaft, okay. So it may be difficult if you have to stretch the belt and put it in, okay. So it's not like a normal rubber band, okay. Even though it is slightly stretchable, but you may not able to stretch it directly, so there will be a slack side, okay, and you may need to tighten it, okay, by using an additional idle pulley, okay. So this one maybe there is a screw, okay, so that you can screw until it tighten, and that's all, right? So this is the idea of the idle pulley. And also why we need the idle pulley is because the belt length is I would say it's not continuous, meaning to say, if let's say you want this distance, okay, and this length, maybe this whole circumference, when this is tight, right, maybe 35 millimeter, right, but then let's say 35, okay, but then when you buy this belt, okay, the manufacturer may only have 36, okay, 36 millimeter, okay, then therefore there is additional 10 millimeter 1 millimeter that you have to tighten through this, okay. So if this is okay, I think centimeter is better, right? So if this is centimeter, then you will see that there is a 1 centimeter looseness, okay, over there, okay. So sometimes this is 38 or 40, they don't sell 35, right? So that is why you need this idler pulley, okay. You can also compound them together, okay, from one combine to the other one, right, okay, because you need further reductions, okay, that you will see later on, that when you combine these two pulley, okay, the angle of the wrap itself is also important, okay, to define as I say the contact area, right, is important, okay. So this is the contact area between the shaft and the pulley, right, and same thing, okay. So if there is a very large, okay, and a very small, right, so you will notice that in this case it's okay, but then this side, okay, the contact area will be too small, right, therefore you need a multiple compound of belt drive, okay, to combine them together, okay. So again, the V belt and the flat belt, okay, why V belt are more common, because it has several advantages over the flat belt, okay. That includes the compactness, okay. The compactness means you can have a smaller distance, okay, because of the larger contact area, okay, due to the V shape itself, okay. Also the drive is positive, okay. When we say a drive is positive, is that we can assume that the slip between the belt and the groove is negligible, right, whereas for the flat belt they may have some slippage, okay, in between them because of the contact area itself. Then also since the V belt is made endless and there is no joint trouble, therefore the drive is quite smooth, okay. The V belt generally have a longer life as compared to the flat belt, okay, and is easily installed and removed, okay. You don't have another problem like the belt get loosened, okay, and fall off the pulley itself because of the construction where you have a deep groove, okay, to maintain the positions over there, okay. The belt and pulley is also quite quiet, okay, and so on, right? So these are the other advantages, okay. But then the V belt have several disadvantages, okay, where it cannot be used with a very large center distance, okay. You cannot have here maybe on the other side, even though it's flexible, okay, the large center distance may not be good, okay, because of the weight per unit length, okay. So the belt itself have weight, okay, you have to remember that, therefore it will tend to bend, okay. And because of this you have other problem, okay, when the stretches is too long, right? Therefore again, if it is very long in between one end to the other, then most probably you may need to consider other type of drive. The constructions of the V belt is more complicated for sure, right? And then it's subjected to creep and other things, right? Okay, so now we come to the belt drive design, okay, how we can go to estimate and select a proper belt, right? So in the belt drive design, generally we are talking about the selection itself, right? The selection is more important than we are not designing the belt, okay, but we are designing the system of the belt, right? So in designing the belt itself, we have to get the general idea of the constructions, okay. You have the shaft, okay, what is the diameter of this shaft, we have to estimate, or we should know before that, all right. Then only we can start to design this, okay. But then how we can know this too, okay, if we going to buy it, okay, from the manufacturer, then we have to select from the dimension that is given or provided by the manufacturer. So therefore this diameter, the D1 and D2, okay, there is a ratio. So this ratio represent the reductions that you want, okay. So you want to reduce the speed from certain number, okay, or a certain factors, okay. So maybe let's say you want to reduce it to 3 times, so this ratio also have to be in that ratio, okay. It should be matched, okay. So you have to try and error from the manufacturer's shaft or the pulley diameter, okay. You just find the best combination between these two, okay, to get the 3, right? Then from there also you have to know or estimate what is the distance between that 2 pulley, right? Whether if this is too long, then you may need to add additional or you will need to compound it with another set of belt drive, right? So we have the center distance, we have to define this center distance. Then this span is to identify what is the length of the belt, right, that we need, okay. Then also the wrap angle, okay, angle of wrap for pulley 1, pulley 2, okay. So this is the general idea, and from this, okay, we can also know what is the VB, okay, the belt speed you can estimate, okay. V equals to R omega, right? So if you know the rotational speed of one end, then you will know what is the VB, okay, the belt speed, right? So that will be useful for us to design or to select properly. So we can estimate the belt drive and the belt speed as such, okay, is related to the rotational speed, okay. So D over 2 is the radius, right? So R omega, okay. So we also can find the ratio of the shaft, okay, and this is where the reductions comes in, right? As I mentioned, they are related, okay, but they are inverse proportional. Okay, then also we can estimate, or we can theoretically calculate, okay, using these equations. Once we know the d2 and d1 as well as the center distance, okay, we can estimate the length, okay, or the pitch length we call it, okay, for our system, or for our belt itself. Okay, this is the contact angle that you can calculate or estimate using these two equations, right? So you can calculate the wrap angle between them, right? The length of span, the S, okay, we can also estimate using these equations. So it's just about which equation to use, okay? So don't worry about that. You can always refer to textbook or notes or what, or internet, okay? So the equations are standard, right? It's general, okay? So this is the standard belt cross sections, and in general there is a standard, right? So that's why there is A, B, C, D, E, and also 3V, 5V, 8V, and so on, okay? So this is the standard of the belt constructions, okay? That's being made according to the American standard, right? So you can always get the, again, similar to the bearing, you can always get the specifications, okay, from the manufacturer website, right? So this is where I get from this the catalog from this gates.com, right? Now how, the question is how we going to design, okay? What are the requirement or data that we need, okay, where to enable us to select a proper belt. So first thing first, okay, we have to know what is the power of the driving motor or machines, okay? That is the power that we are going to transmit, okay? And that is the most important thing, all right? Because we will intend to transmit one set of power to the other end, okay? That's what this belt must be able to carry or to transmit this power, right? Then based on that, we have to know what is the service factor based on the type of load, and so on. We can other accordingly we can calculate the center distance between the two belts, okay? So maybe you are limited, we are being limited by the box, okay, where you have your pumps, okay, right, and you have your motor over here, right? So it depends on how it is being set up, okay? How sometimes it's very dependent on the I would say the environment or the working space, right? So if you have very limited working space, whereas you have another machine here, then your working space are limited, then you have to design accordingly. That's what that will detect your center distance, okay? But then if you have no limitations, then the center distance is up to you. You just select any numbers that you like, right? Then also the belt length, the angle of contact, and so on, right? So again, based on this idea, right? So if it happens that in an existing system, okay, let's say you are working in the oil and gas company where you have a centrifugal pump to pump waters, okay, to maybe to supply a cooling water, okay, to a certain part of the machines, right? But then we notice that this belt always fail, okay, or doesn't work at the highest efficiency. Therefore from there we can help to check or maybe redesign or to reselect the proper type of belt, okay, to maintain or to increase the efficiency, okay? It can be because of the improper belt being selected, okay, therefore it's always fail, not there, or maybe the the pulley is not working properly now. Okay, it have a lifespan where it doesn't really connect, right? But then it's very rare this would happen, okay, for a properly designed system. Okay, then also when we install it, okay, this is the correct way. If it is too deep inside the groove, then this means incorrect. Okay, so how to design, again, it's come from the belt manufacturer's catalog, right? There is where the performance and the lifespan of the talking. Okay, so it depends on the type of applications. Okay, if we are using the AC motor as a as our driving machines, okay, and if we are using it for maybe 3 hours to 5 hours per day, okay, or seasonally, then depends on, again, type of the thing, then you can select the service factor, right? So this service factor is similar like a safety factor, right? So if you are intend to drive the power of 30 kilowatt, all right, so and you are using it for a printing machine, okay, where there is maybe a small shock, okay, a jerking, okay, therefore that's why we will select 1.1, so we just multiply by 1.1, right? So this become 33 kilowatt, okay, that we gonna use for our design purpose. Okay, so we will design for 33 instead of 30. All right, now when we come to the selection part, again, this chart will be useful. Okay, this is a chart for the ABCD type belt. Okay, if we select, if we want the CV, 5V, 8V type, okay, there is another chart. Okay, you can always get this from the manufacturer catalogs again, right? So how to select which type, right? So each type will carry a different power, okay, at a certain speed. Okay, so therefore if you know what is the rotational speed, okay, the highest speed of your shaft, right? So let's say it is going to operate, your motor is operating at 2500 rpm, let's say, okay, that would be the fastest shaft speed, and you are going to carry, let's say, okay, sorry, 20 horsepower. Okay, you are going to carry the 20 horsepower, or maybe, okay, we use back the previous example, 33 horsepower, okay, instead of kilowatt, right? So 33 is over here, so what we do, we just draw a line, okay, intersect them, and it fall to this category. Okay, so therefore this chart will tells you we should select B or BX type. Okay, first we have to identify the type of the belt we are going to use, right? So once we know the type of the belt that we are going to use, then we can also match it with our shaft. Okay, remember the pulley, right? There is a diameter. Okay, so what we need to use is to use the datum diameter, right? So datum diameter, okay, so you have your pulley, so we have to select which combinations we want, right? So this is where I will told you previously. Okay, you just find the combination of it. Okay, so if we select 10 and 5, the ratio is 2. Okay, so you reduce the speed by half, right? Or maybe increase the speed by 2. Alright, so I'm not sure which way you are going to use, alright, which one is the driving and so on. So you have to find the combination of it, okay, to match your desired speed reductions. Right, this is the C shaft, right, and it should be matched with the C type belt, right? So this C shaft, okay, if we are going to select C, alright, so this example is just to show you if we fall into the C shaft, then we will have this. Okay, find the combinations, and now once we know the type, now our challenge would be to find the, okay, before that, based on this ratio, okay, you can now calculate the L, the span, the center distance, okay, based on the center distance, okay, then you can calculate many things from these selections of the diameter or the datum diameter of the shaft itself. Okay, so now come to this, when we know the type of the belt, what we need to do now is to select, right, the exact belt. Okay, what is the belt? Okay, type is C, but then which one, okay, of C. So you will see there is a belt number, right? So you can see at here there is a belt number, right? So let's say now your speed is, just now is 2005. Okay, let's say now we change. Okay, so the driver speed is 1000 rpm, let's say. Okay, if this is 1000 rpm, then we have to do interpolations, right? So what we would do now is we find which ratio we want, okay, the datum, the center distance. Okay, from there we can now check, okay, which one would carry just now 33 horsepower. Okay, so we can see that here 33. Okay, so this one cannot, this one 33. Okay, and then this one 33, right, C type, okay, and above, right? So therefore you can see that at certain stage it is not suitable, right? There is no data and so on. Okay, but if we use the CX type, then this is 33 at 1000 rpm, so we would have to find somewhere here, right? So we will start with somewhere here 33.9, and we use this value assuming there is some value here, so we interpolate, right? Do the interpolations. Okay, this is 870, here is 1750. Okay, we want to know what is 1000 rpm, the rated power that it can carry. So this is 33.92. okay, this is another number, right? So we interpolate accordingly. Okay, so now before we do a selections, what you need to know, there are 4 things, okay, which being recommended by the catalog. Right, just a reminder from there. Okay, the type of applications, this is where we are going to select the service factor, right? Then also the power rated, okay, at the speed, and from the speed we need to know what is the speed ratio. Okay, and finally we estimate the center distance. Okay, what is the center distance required between the 2 shafts. Okay, this is again the design step for a V belt, right? You find the horsepower, find the cross-sectional type, okay, the speed ratio, choose the diameter from the catalog, okay, then calculate the center distance, then select the V belt number, okay, and then as given by the manufacturers, okay, according to the type of the belt, then they will tells you the installations considerations. Okay, for example, what is the installation length, the take up length, the center distance, take up length, right? Installations. Okay, so it will be given by the manufacturer catalog, right? Then check the pulley crown and the width of the, maybe if it is a flat belt, then we have to check, all right, all these things. Then the final part would be according to the manufacturer guide, okay, what is the belt tension required. So these belt tensions will give to ensure that the belt will not slip when we apply the design load. Okay. Before we move to the next part, any questions so far? If you have questions, you just put it in the chat box, okay, and we move on and we will answer that at the later part. All right, any questions so far? No question yet. All right, so maybe to save time we just move on, okay, but you can keep putting in your comment, okay. We will address that at the end of the sessions, okay. So this would be another flexible type of drive, okay, where we use a chain, okay, instead of the belt. The chain drive have a similar idea or the constructions, okay, with the belt, okay, but then there is this we call chain, right, and this chain itself there is a various again you can have different standard, okay, or maybe different strain, okay, single, double, and so on, okay, the way it is being constructed. So in the chain drive is the main driving part, okay, is not through friction, okay, but then it's through this pin, right? So the force is being transmit, okay, like a gear transmit to the chain through this, right? So this pin is important, okay. So generally that's why when we select again the sections of the chain would be given by the manufacturers, okay, for this type, okay, or the chain number, what is the maximum power or the rated power that it can transmit, okay. So this is the idea of when we select the type of chain, right. The basic feature include the constant ratio, okay. This one for sure there is no slippage, okay, or no creep, okay, long lasting, okay, just like one you use in your motorcycle, okay, and it's able to drive a number of shafts from a single power, okay, meaning to say you can have one power, okay, in between you can have 1 and 2, okay, but very rare, right, but generally you can have more than one shaft in between them, okay, because the transmission of power is in between the roller, the pin at the chain and your sprocket. Alright, so we use the sprocket, okay, to transmit the power, okay. Therefore they can have a single, double, triple, quadrat strain, okay. So this is the strain, okay, one strain, two strain, right, and this is the width, this is the pitch, okay, the pitch length, and this is the pin or the roller itself. Okay, so in between the strain there is a spacing between them if you intend to have that one, right. So now what are the considerations that you should make when we design for the chain drive, okay, or the considerations are very similar to the belt, okay. So basically it is same, okay, basically it is same with the belt, okay. You have to consider the type of applications and so on, right. So we will go through that in the later part, okay, through our design step, okay, and then how to obtain the required information. Again, it depends on as we have discussed for the belt, it is very similar. Again, it's come from the catalog if when we want to deal with the informations about the chain, but then as the setup of the machine itself, then this information may be come from the observations of your environment, okay, the space required, okay, and other things, okay. So this is where you can collect all your informations, okay. And also as you have learned previously in the conceptual design, okay, so you have to know what are the major issues or problem that you are going to solve, okay, when you design this particular system, okay. So this is where you gather all this information for your concentrations, okay. So the service factor, again, you have something similar, right? Depends on the power source, okay, whether this is a combustion engine. Combustion engine means any engines, okay, diesel engine, gasoline engine, and so on, right? Or it is electric motor. You will notice that in the previous belt, they only generally they put a AC motor, okay, because they don't expect us to use the belt with the engine, okay, because the engine is very hot, right? So it will affect the lifespan of your belt when it is being used closely, okay. But then for a chain, this is the case, okay, where you have the options of electric motor and the engine itself. Again, we can separate them into different type of impact, okay, according to the machine, alright. So you have a centrifugal blower, okay, and so on, okay. Beside that, in the previous belt, okay, I do not mention about multiple belt that we use, okay. So if you are going to use multiple belt in the belt design, then you just have to divide by the number of belt, okay. But then for drive design, we do not divide by the number of strain, okay, because of the constructions of the chain, okay. You will see that they are actually connected through maybe a single roller, okay, sort of connected in the single roller or pin, okay. Therefore they have this factors to multiply instead of the number of strain, okay. So if we are going to use 1, then we divide by 1, but then if we are going to use 2, we don't divide by 2 anymore, okay. We divide by 1.7, okay. If we are going to use 4, okay, if we are going to use 4 strain chain, okay, then the power factor will be 3.3 instead of 4. So when we design for the required power, okay, so our power required would be equals to the power multiplied by the previous service factor, okay, which define our power input, okay, divide by the strain factor, right? This is the dimensions of the standard strain, okay. So most of the catalog, they only show for a single strain, okay. And how we are going to design for multiple, so we have to use this, okay. So when we divide it, we obtain the power that is going to be carried by a single strain itself, okay. So this is the general informations about the pitch, the width of your chain, okay, that we are going to select, okay, and also the general conversions unit, okay, from inch to millimeter, horsepower to watt. Now when we come to the design, then again we want to know what is the diameter, okay. So this is the diameter that we going to actually the diameter that's going to transmit, okay, in general, to transmit the power, okay. So we can always estimate this, okay, using these equations, okay. And this is related to the number of sprocket teeth. Okay, how many number of teeth is okay, and also from that we have to use we have to know what is the chain velocity. This is very similar to what is in the belt, right? But then we try to re-express them in terms of number of sprocket. Alright, so therefore there's a number of sprocket, the sprocket speed, and so on. So the sprocket speed is our omega. Alright, from these equations also we can estimate the maximum exit velocity and the minimum exit velocity through these two equations. Okay, so these two equations will tell us what is the speed variation, okay, because there is a movement when it is driving, the belt intend to like vibrate, right? So that's what there is the variation in between the maximum and the minimum, right? And there is this speed variations. Okay, so if the number of teeth is very low, okay, when the number of teeth is very low, therefore this speed variations is very high. Okay, it can go up to 25%, okay, variation, which we do not want. Okay, therefore in general we would want to select, even though we want a smaller sprocket, but we intend to choose at least 17. Okay, so if it is about 17, then the speed variations will be much lower, which is maybe 2 to 3%, okay, of the variations that we intend to design. Okay, and also because of the lesser variations, okay, the lifespan also increase, the noise also decrease. Okay, so this is the idea of why we select at least 17 number of teeth. Okay, so this is required to be keep in our mind when we design. Okay, we want smaller sprocket, but then start with about 17 teeth and above, right? So this is the reasons why. Okay, then when we select, again, it depends on our data table from the manufacturers. Okay, so this is the data table, something similar, right? But then we would see that there is this number of teeth, right? So even though you can select from 11, okay, the best we select from here. Okay, if no choice, then okay, never mind. All right, but if we can try to avoid, right? So this is the single strain for a chain number 40. This number 40 is the type. Okay, for the belt we have the A, B, C, D type and so on. So in the chain we have the type called number 40, 60 and so on, right? So this is the type number, right? Not, and this type number could be applied to different number of sprocket. Okay, if it's 10, 11 and so on, and this is the rotational speed. Okay, so if we intend to use it for 1000 RPM, okay, and we select the number of teeth is 17, therefore it can be worked for a horsepower of 7.27. all right, so this is the power that it can transmit, okay, at this speed and this number of sprocket, number of teeth of the sprocket, right? So this is how you can select, okay, based on the power required. Okay, you have to select, okay, which numbers that you can overcome that, right? So if let's say our power required is 16 horsepower, okay, if it's 16 horsepower, then it would be 4 in this range, 16, okay, 16, right? So So we have to select somewhere here, right? So if we intend to use 1000, so these are the available number of teeth that we need to use, okay, in order to carry the that amount of uh, power being transmitted, okay. When we increase the number of teeth, actually we increasing the number of contact, okay, of the teeth of the sprocket that try to transmit the power. All right. Then also you will notice that at the bottom there is type A, B, and C. This type A, B, and C represent the type of risk required. Okay, if you are selecting in this range, okay, then you just need a manual or drip type of lubricants. Okay, but when we select the type B and type C, then you need a different way of lubrications. Okay, and the methods of lubrications is getting complicated, right? So this is how you can achieve the type 1, type A, type B, and type C. Okay, type A, B, and C, okay, of lubrications. Okay, therefore you can see some motorbike, they need to put in the oil, right, and so on. Okay, so this lubrication is important because of the moving part, right, and generally it is a petroleum based lubricant. Okay, so this is how you can achieve the lubrications, right? For the design guide, generally, okay, again 17 number of teeth, okay, unless it is at a very low speed, then you can choose a smaller one. Okay, then also maximum speed ratio, try not to be over 7. Okay, if it is smaller than 7, then we can consider to use a compound type of chain drive. Okay, you just compound them into several 7 speed ratio. Okay, you multiply both, then it becomes very high. 7 multiplied by 7 it becomes 49, right? Okay, then also we need to identify the center distance. All these equations for the center distance is exactly the same with the belt, okay, because it's still the same concept. Okay, 2 circles being connected through a flexible drive. Okay, therefore you can estimate the center distance using the same equations with the belt, right? Then also usually the large sprocket do not have a teeth more than 120, right, and the arrangement it should be considered. Okay, especially you would generally want the tight side on the top. Alright, so you can see the equations exactly the same with the previous one. Alright, then also we can calculate or estimate the pitch diameter of the sprocket, okay, as given as so. Okay, and the minimum diameter, maximum diameter. Right, so also this is the contact angle, okay, exactly the same like the previous, right? So now we would go through one examples from this design book by Robert Note, right? So you can see that this is a chain drive, okay, where the motor or the engine, okay, this is the engine, okay, being located at the bottom of your conveyor, right? So this conveyor is a heavily loaded conveyor, okay, used in the commercial to produce farm, right, to carry potatoes, okay, from the field to the truck. Okay, so there is a large amount of mass, okay, being deposited on top of this. Okay, and we can see that the gasoline engine here have a rated power of 15 horsepower at the speed of 900 rpm. Okay, therefore the pulley speed, now we intend to be in this range, okay, so that the potato will not move too fast and fall off and so on, right? So design a chain drive for this, right? So again, this conversion unit is I put it here, okay, just a general reminder. Sometimes it is in horsepower, sometimes it's in kilowatt, okay, sometimes it's in inch and so on, and the catalog again sometimes is in different units, so therefore you have to know how to convert them and use it, right? But then for the equations, exactly the same. So now what we are given is clearly stated, right? What we do now is to select the service factor first, okay, the design power, right? So since from what we have seen, this gasoline heavy duty conveyor, gasoline is an induction combustion type, okay, heavy duty conveyor, general, okay, so with load fluctuations, okay, heavy duty type, okay, so without hydraulic drive 1.4, right? So we put in 1.4 over here, right? And we get 21 horsepower, okay? Now if we start with this design, okay, and we want to use one single strain, then we don't have to divide anything. This divide 0.1, right? So one single strain, so the design power remain the same, right? So using this design power, now we need to also identify what is the desired ratio, right? So speed motor 900, this is the range that we want, all right? So since 230 to 240, so we just take a midpoint of them, okay, we divide, so we roughly estimate the ratio should be 3.83, right? So from that we can choose the proper combinations, okay, that give us that, okay. But then if we start with 17 number of teeth, okay, 17 number of teeth, so 17 multiplied by that ratio, the next sprocket number should be around 65, all right? So we just check, okay, whether there is 17 and 65 in our catalog, 17 or 65, right? So you can select the number of teeth from there, right? Also this is 21 horsepower, okay, so 21 horsepower, you can see that this is the range that you can have, right? But we start with the lowest 17, then it will start at this number, okay. So again, since this is 900, okay, in the design, and you don't have 900 in the spec, okay, in the data table, what we do, we interpolate these two values, okay. So if this is the midpoint, then it's easy, you just get the average of this, you will get 1924, so it's roughly 22 probably, right? 22 horsepower over here, right? But in the test or when you do your calculations, you have to calculate the exact value, right? Now based on that, since we already have this, we can double check again, okay. If we choose 1765, okay, at 900 rpm, what is the speed? So if we get around 235, then it's fine, okay, it's within the required range, okay. So once we get all this value, the n1 n2, then now we can estimate the pitch diameter, okay, using the equations, and also we can calculate the center distance, okay, the length, right? So again, there is a center distance typically used, okay, within a certain range, okay. Again, we don't want it to be too far, okay, because of the weight, okay, it will keep flipping, okay. If it is too long, then it will start to flip, okay, and it will cause a lot of vibrations, right? From there, we can also estimate what is the length, but then now in the chain the length is not in millimeter but is in number of pitch. Okay, number of pitch, which is 122.5. okay, remember the chain itself is being constrained by the roller or the pin, okay, in between them. Okay, so every single of this there is a distant pitch. Okay, we cannot suddenly have a smaller one, right? So therefore if we get 122.5, there will be never have a half one, right? So you can choose the nearest one, maybe 123 pitch, or okay, any number available for you, right? Okay, so let's say they use 122 pitch. Okay, slightly smaller is okay, right? Because it is being estimated by the length, right? So this length, it can be increased or decreased. Okay, so that's why if we get 122, then okay, then from that we can calculate the center distance, okay, to put in, so that we can adjust our machines in between them, right? And identify what is the right angle. Okay, should be 120. Okay, so if 120 acceptable, that's it. Okay, so this is the summary of your design. Okay, so you can see that the step is so-called iterative. Sometimes it's not working, you recalculate. It's not working, just recalculate, right? So let's say in the exam it comes out that you do the iterations, okay, several times. So you don't have to actually come into several times. Okay, you just write maybe one time is sufficient. Okay, but just the worst case, if you select the wrong thing, then that's why you need to do the iterations. Okay, in general maybe roughly one time is good enough, okay, to come up with this design, okay, when we have sufficient number of informations, right? So that's all for this part. Any more questions? I don't see any questions yet. No questions? Okay. Okay, so if no questions, we will end this sessions, and for the next class, okay, we will try to do it next Friday again. Okay, next Friday again, so that we have maybe one more weeks. Okay, if there is any cases, then we have additional week to do. Okay, otherwise we will be very tight. Okay, so we will have our next sessions next Friday. Okay, same time, right? So that's all for today. If you still have questions, you can always ask, okay, through various channel, okay, WhatsApp or whatever, right? So that's all for today. See you again. Bye bye.